In this video, I'm going to show you how to add and subtract polynomials. I'm going to review how to multiply polynomials and then show you one with variables. So the first example here says to find the sum of the two polynomials below and write your answer in standard form. So since you're adding, you would only be just distributing a positive one, so it's really not even necessary. I like to mark up my like terms kind of with a pen, with symbols, with lines, boxes, triangles, that sort of thing. So anyway, the x cubes are going to be 2x cubed plus 1x cubed, so 3x cubed. My x squares are the negative 5x squared plus 6x squared, so that's going to be 1x squared. It's up to you if you'd like to put the 1 there. And then my x term, there's only one, it's just the 3x. And then I'm going to put triangles around my constants. So I have negative 9 plus 11, so that's just going to be plus 2. And then this is written in standard form. The variable is alphabetical. In this case, it's just x, and then the exponent is decreasing. All right, so now I'm going to jump down to a subtraction question. And now it's going to say find the difference between the two polynomials. So this one you have to distribute the negative 1. So you want to multiply through by negative 1. So I'm going to go ahead and do that. So I have 8x cubed minus x squared minus 5x minus 3x cubed minus 2x squared plus x minus 7. And then now you would do the exact same thing where you combine your like terms. So I have the x cubed, so 8x cubed minus 3x cubed is 5x cubed. And then the x squares, this time I'm going to circle. Doesn't really matter what symbol you use when. So minus x squared or negative x squared minus 2x squared is going to be minus 3x squared. And then this time I have multiple x terms, so negative 5x plus 1x would be negative 4x. And then finally left over is just my one constant term of negative 7. And again, this is written in standard form. All right, so now I'm going to go on to some multiplication. So that is on page 3. To multiply polynomials, distribute everything in the first parentheses to every term in the second parentheses, then combine like terms. So for all of these, the instructions are the same. Find the product of the two polynomials below and write your answer in standard form. This example 5, you have a binomial times a trinomial. So when it's kind of in standard form where you have an x plus or minus a constant and then a trinomial of degree 2 with the same variable, it might be helpful to kind of stack it. So I'm going to distribute the x. And I'm going to do x times negative 2x squared, so that's going to be negative 2x cubed. X times 3x is 3x squared, and then x times negative 6 is negative 6x. And then you're going to do the same thing with the negative 2. So negative 2 times negative 2x squared is going to be positive 4x squared. And this is where I'm stacking it, where I want them aligned by the degree of the exponent. So I'm putting the x squares on top of one another. And then I have negative 2 times 3x, that's going to be negative 6x. And then negative 2 times negative 6 is positive 12. And you can see that that kind of makes the addition or subtraction a little bit easier. So when I put them all together, I get negative 2x cubed plus 7x squared minus 12x plus 12. And that's all that you need to do for that one. The next example is when a binomial is times a binomial. I know some students really like the box method, and that's fine to learn in Algebra 1. But as you go on to Algebra 2 and pre-calculus, we really don't want to see you doing the box method. So all right, so now I'm going to distribute the 2x. I'm not going to stack it this time. I'm going to use FOIL, first, outer, inner, last, or double distribution. So I'm going to do 2x times x to get 2x squared, first times first, first times last, or outer, the outer first, and the two furthest away from one another. So 2x times negative 4x is negative 8xy. And then the inner 2 is distributing the 3y to the x, and then the last is the 3y to the negative 4y. So I'm going to get plus 3xy minus 12y squared. These two can be combined, so I'm going to go ahead and do that. So I have 2x squared minus 5xy minus 12y squared. All right, the next example has two variables. It has s's and t's. S's are always kind of tricky because they look like 5, so just be careful with that when you write your terms because it could very easily look like 35 instead of 3s. Go ahead and distribute the 3s all the way through. And this time I'm going to write it as one long line. So I have, here I am doing it. All right, so I have 3s to the third, 3s to the third, minus 9s squared t, and then 3s times 2t to the third is plus 6s t to the third. And then I have 2t times s to the third. So I'm going to write it as 2s to the third t because I do want my variables alphabetical. And then I have 2t times negative 3st, so that's negative 6s t squared. And then finally, I have positive 4t to the fourth. All right, now I want to write my answer in standard form. So there are no like terms in this particular case, but the first variable is s. It should be written before the t by term, and then you want the s descending. So you want to start with the s to the third, then the s squared, then the s to the third, then the s squared, then the s, and then the constant. In this case, there's not a constant, but I'm going to start here with just the 3s to the third because this one has no t, and I'm going to cross them off as they go. Otherwise, I think it'll be really easy to lose a term. All right, so here is s to the third, then t. Here's s squared, then t. So I have 2s squared t. Then I have s t cubed and s t squared. So I'm going to do this one first, so negative 6s t squared, then positive 6s t to the third, and then finally positive 4t to the fourth. And I'll move that up so you can see it. All right, the last example that I wanted to do with you is a little bit harder. It is on page 5. It's the top of page 5. It's example 8. And this is where you are finding page 5, number 8. So this one here. Find the values of A, B, C, and D that make the equation true. All right, so I would recommend that you distribute through your negative because it's very easy to make errors with that. So I have the ax cubed minus 3x squared plus 2bx minus 2 minus 2x cubed plus cx squared plus 5x plus 4d equals my trinomial on the right, which is the x squared plus x minus 6. It's an awful lot to say. All right, now what I'd like to do is match things up by variable. And you'll notice on the right, I have 1x squared plus 1x minus 6. I am missing an x to the third term. So it's really like there's 0 x to the third on the right-hand side. And now I am in a color code, so I want to put the terms together by variable. So I really want to look at the coefficients here, not just the terms. So the coefficients on the left are the a and the minus 2. So a minus 2 has to match up with this 0. Okay, so when I solve this out, I'm going to get a equals 2. All right, and now I'm going to go to pink. Hopefully it comes out this way on the screen. So here's my x squared. Here's another x squared term. And on the right, I have the 1x squared. So when I look at those coefficients, I'm going to have the negative 3 plus c equals 1. So I'm going to add 3 to each side and get c equals 4. And you can hopefully see the pattern now. I'm going to circle this with red. So I have positive 2bx, 5bx, and positive x. So then that coefficient-wise would be 2b plus 5, just looking at the coefficients, equals 1. Slightly more challenging, but not very much. So I'm going to subtract 5 in my two-step equation. So I get 2b equals negative 4, divide by 2, and I get b equals negative 2. And then last but not least, I think I have a blue. Here's my constant. I have the negative 2, might be a little hard to see, and then the positive 4d and the negative 6. Kind of messed it all up. You probably can't read it very well. So I have negative 2 plus 4d equals negative 6. And then I would solve, so add 2 and divide by 4, and the math comes out nice yet again, and d equals negative 1. All right, I hope this is helpful, and can't wait to see you again in person.